I discovered Bitcoin back in 2013 when I was studying economics, and I quickly fell into the rabbit hole and started telling everyone about this fascinating phenomenon. So all my friends, all my family members, etc., has been very tired of hearing me going on about this since 2013, never stopping. So it's always good with a new audience that is keen on actually hearing me talk about this, because there's something about this sector and this technology that has an extreme pull on people. It's something truly interesting here. So in my presentation, my thinking was to talk about primarily Bitcoin and blockchain, and try to shed some light on what it is and what it isn't, and why those differences are important. A lot of people have heard a lot of claims around both Bitcoin and blockchains that are very often not true and gives wrong impressions of what you can do and what you can't do with these technologies. Also, a lot of people think that these concepts are primarily technological, while in fact, I would argue, especially coming with an economist's background, that they are as much, if not more, social constructs enabled by technology rather than pure technology. But to frame the whole presentation, I just wanted to kind of remind people of, or at least what in my view, is the true transformational power of the internet. So what the internet did for the first time in human history was to enable permissionless and borderless sharing of information at scale. Permissionless meant that anyone could go online and launch their own TV series, their own newspaper, their own, like, regardless of what type of information they wanted to share, they could do so without having to ask for permission. Prior to the internet, you had closed and specialized networks for handling information. You had a phone network optimized for handling kind of phone calls. You had different spectrums you could broadcast radio. And if you wanted to have a radio station, you had to apply to get access to a spectrum. And if you wanted to have a TV show, you would have had to kind of pitch your idea to a broadcaster like the BBC or NRK here in Norway and get permission. Removing this barrier, this kind of having to ask for permission, is what made internet extremely interesting. It made that anyone with any idea could try it out, and made it a very interesting evolutionary platform where a ton of bad ideas got tried out but died, but also some really strange ideas that turned out to be good were allowed to be tried. So the internet did this for information. But what was really lacking was a similar type of infrastructure to handling value. Not only money, but all forms of value, access to intellectual property, like videos or music, identity management. There were no way to do that online in a permissionless and a borderless fashion. And the reason was basically that on the internet, unless you had a third party saying who you were interacting with, you couldn't know if it was a dog or not. And for that reason, the internet that started out as something very decentralized and very open has collapsed into these kind of platforms and silos in the form of Facebook, Google, Amazon, built around also payment providers like Visa and MasterCard, or identity providers such as kind of Bank ID here in the Nordics, but also kind of Google, Facebook also being very important in identity management. Because to handle value, information that needs some type of owner online, you had to have this type of third-party provider. It's also actually interesting in this regard to think about the whole internet structure itself. The domain names, the fact that you have a human-readable short domain name like google.com, the fact that you can go there and be certain that you are on the right page is actually only possible because you have an organization called ICANN combining that domain name with the cryptographic certificates or the cryptographic keys, if you like, and keeping that list of cryptographic certificates paired with domain names, so that even the internet itself, in some fashion, is centralized because of the domain name system. All username systems had to be centralized and centrally managed. This was true up until 2008, when an idea, why is it not shifting, was circulated on an email list for cryptographers. A group of people or an individual called Satoshi Nakamoto shared an 8-page document laying out the architecture for a peer-to-peer electronic cash system, but without any intermediaries. A way to transfer value on the open internet, on the permissionless internet, in a permissionless fashion without intermediaries. This has turned out to be a truly transformational breakthrough. Interestingly, though, this breakthrough was not primarily technological. All the technological components in Bitcoin existed way before this paper. The breakthrough, as I'll come back to, was primarily game theoretic. The use of the cryptocurrency token as an incentive mechanism to get consensus without having some single source of truth, some centralized intermediary giving you that truth. Linking this back to these domain name systems, is actually interesting that you had a concept called Soko's triangle around domain names, where the hypothesis or idea was that you couldn't have human-readable, secure, and decentralized domain names. You could only have 2 out of 3 of those. And it was actually someone who wrote a paper identifying Bitcoin in the light of a domain name system and referenced Soko's triangle as a proof of Bitcoin as something that couldn't work. But actually, a guy called Aaron Swartz, who's very well known in circles of kind of internet activists and one kind of very early pioneer, understood that actually Bitcoin squared the so-called triangle. Bitcoin is actually a solution to what many call the Byzantine generals problem. So the reason I'm bringing this up is because it's a little bit interesting, at least to me, from a very nerdy perspective, that Soko is actually the guy behind one of the cryptocurrencies that are out there called Zcash. So you see a lot of the same people who's been early pioneers in internet technology has also been very instrumental in the early stages and early part of the life of Bitcoin. When you hear about Bitcoin, a lot of people will tell you that, well, it's interesting, but it's too volatile. It's consuming too much energy. It's old, it's outdated, it's the first, it's like the MySpace, but something better will come. The true innovation is the blockchain. That is what's going to transform the world. Most people who say this, though, don't try to define blockchain, or if they do, they kind of do it in very vague and broad terms. They do it along the lines of some magical distributed database that can solve all your digitalization problems. If only the value chain had a blockchain, there wouldn't be any more paperwork. If only there was a blockchain for elections, there couldn't be fraud. Of course, this is utter bullshit and has nothing to do with what a blockchain actually is. Because technically speaking, a blockchain is something very precisely defined and very boring. It's an append-only log. It's a way to store data structure, where you add new data without deleting old versions of the data. And you link the new data cryptographically to previous states of the log. And before the Bitcoin white paper, this was actually called a cryptographic linked list. This wasn't something new. The way that the term is being used, however, is more broadly. And people talk about kind of blockchain-based networks as some form of kind of decentralized consensus networks. If you take that understanding rather than the precise technical understanding, it's then very important to differentiate along a couple of axes. For instance, is this network permissionless? Can anyone participate freely? Or do you need permission to kind of participate in a network? Also, you have to ask the question of, is it public? Is it available for anyone to see what is happening in the network? Or is it a private network? And depending on where you're landing in these kind of permissioned, unpermissioned, public, private space, has really important implications for whether you should use a technical kind of the blockchain from a kind of the append-only log at all, and also has really important implications for whether it's actually something new or not. And I'll come back to that. So what is the point of a blockchain? Well, since it's a log, it almost gives itself. The whole point of a blockchain, regardless of what system you're using it, is to serve as a timestamp server, to order transactions in time, to be able to say what happened before something else. So when you then have these different types of networks, these private, this public, this open, this closed networks, using blockchains as a timestamp server, as a way to kind of sort the time in their network. What is the value of this? What can they contribute? Well, there are actually some use cases for private or enterprise blockchains of having a shared ledger. It can make reconciliation between collaborating parties, whether that's banks or participants in a value chain, easier. However, this requires coordination. The technology for doing this type of distributed ledger is way older than Bitcoin. In Estonia, they've had a system called the X-Road since at least 2005, if not a little bit earlier, where they're using cryptography, using most of the same technology as in Bitcoin to securely exchange data between different public entities and public sector and private sector over the open internet. And they could do that way before Bitcoin existed. So when you hear about banks wanting to build some consortium to have an kind of DLT system to be more efficient in their clearing, when you hear about kind of shipping companies wanting to do the same for international trade, it's really important to bear in mind that the reason why this system hasn't been developed in the past is not lack of technology, but lack of coordination. It might be enough momentum right now to get the coordination needed, but most of these projects will fail because they typically become designed top-down as mega projects. And the challenge here is that for complex systems, which kind of a distributed network eventually turns out to be, you have a rule of thumb saying that any complex system that works must have kind of evolved from a simple one that worked first. And that any attempt to design a complex system top-down never works and will have to kind of be restarted with something simple if it's supposed to work. And we've seen this over and over, this mistake of trying to design complex systems top-down. We see it all across society, but we also see it particularly around kind of digital communication and digital kind of now in the blockchain space. Back in the 90s, you had, or in the 80s and 90s, you had a competing network standard to TCP/IP, the OSE standard. Most of the large telcos, most of the large countries got together, coordinated their effort in the ISO kind of collaboration for standards to push out kind of a network standard, to design it by committee, top-down, how digital communication should happen. In Norway, it was actually passed a law for public procurements in the early 90s, where every public system would have to follow the OSE standard. Luckily for us, that law was never really followed up because it was the open and kind of non-designed, but rather evolving TCP/IP standard that actually won. In the blockchain space, we've seen this very clearly with two projects I want to highlight here, in addition to several others. One is the R3 Consortium. So back in 2015, after the spectacular wave of Bitcoin reaching $1,000 per coin in 2013 and then collapsing as the one exchange handling 70% of the global volume, Mt. Gox, got hacked, a lot of people had this idea of using the blockchain in an enterprise model, to use it for interbank clearing. Now we could finally get away from the inefficiencies of SWIFT, of old and outdated systems, kind of get rid of all the mainframes in the banking sector. So the R3 Consortium was founded to build this out. And you had some of the biggest banks in the world going together as this great consortium, funding the development, and thought that they by committee could design such a system. Not surprisingly, though, nothing has happened. You've had a couple of pilots. It doesn't work. Most of the large banks that were initially a part are kind of have left this consortium. You cannot succeed by top-down innovating and creating complex systems. Same thing with Libra, which is now called DM, at least last time I checked, which is this Facebook project, where a lot of people thought that, now we'll have a cryptocurrency that will actually become big. We have Facebook as one of the largest companies in the world with the largest user base, putting its full weight behind developing this digital currency. And they're not even alone. They're bringing in PayPal, they're bringing in MasterCard, they're bringing in crypto companies like Coinbase, they're bringing in Spotify. This will have to be it. Bitcoin can never compete with this. And the fact is, of course, that nothing is happening. Because once you have a committee, you have a ton of questions, and it's impossible to really get to a conclusion. And you have competing companies with competing interests that just ends up going over and over and compete. And again, this attempt of designing a complex system top-down was doomed to fail from the very start. I said so, and several others said so from the start, and it happened. So, and also trying to use blockchain technology to create a permissioned network, to create a kind of closed enterprise network, is also missing the whole point. It's like insisting on using a technology designed for a different purpose, namely being open, having consensus in a permissionless and an open network in another context. If you have a set of parties you can trust, you don't need a blockchain. You can use cryptography and you can use distributed database technology to have efficient sharing of information, but you don't need a blockchain. And I'm insisting on using a blockchain in that context is a little bit like insisting on putting a horse in front of a car, which was done in the 1930s during the shortage of oil. But the problem then is that you're ending up with a cart which is really not ideal for being pulled by a horse. You're removing the whole innovation. Because the true power here lies in the openness. It's the openness of Bitcoin and other public blockchains that enables permissionless innovation, which makes it possible for anyone with an idea to test it out without having to ask for permission first. If I want to sell solar power from my rooftop solar panels to my neighbor, and I want to use, say Visa or Venmo or Cash App or Ipfs, I'll have to go and ask for their permission. On the other hand, if I just do it with Bitcoin, I don't have to ask for permission. I can just sit down, write the lines of code, and do it. An important thing here is that I'm not necessarily wanting to do something illegal. So the fact that I don't have to ask for permission is not important to enable me to do anything illegal, but it's important to enable me to do whatever I want and whatever I think it's a market for. Because if you ask a big payment provider to do a special change to Carter for your use case, they will look at the market size, and if they deem it to be too small, they'll say it's not worth the effort. But with open system, the minimum viable market size is 2 people. As long as 2 people want to share information over the internet using some type of standard, that's enough. If 2 people on the internet wants to use Bitcoin to pay for something in a certain way, that's enough. You really compress the minimum viable market size. Also, it's the openness that enables this exchange of value, management of identities, payments, without relying on middlemen that might take fees, either in the form of selling your data or outright fees or other ways of monetizing and kind of misusing their role as trusted intermediaries. So the really new thing is that we've had system before where we had kind of centralized protocol coordination, like kind of for Excel or Visa, where there are corporations deciding on the standards. But we also had systems in the past where we have decentralized coordination, like email. There's no one deciding the email protocol and enforcing that on people. It's something that we all decide to use. And since email is a open protocol, It means that different clients can send emails to each other. You don't ask someone, are you using Gmail or Yahoo? You just ask what's your email address, and then you can send from whatever client using that general protocol to another client. So you get interoperability. The thing that email doesn't have is a kind of system state that is global. There's no kind of global track of emails, which is a good thing, but it's something that is just between the sender and the receiver, which means that you can't handle value, you can't handle payments. To handle payments, you need to have some type of global system state where kind of the system needs to know who or what kind of, not necessarily in which person, but in the sense of someone needs to own, for instance, say a Bitcoin at a given point in time. But when you then have a decentralized system with a global state where everyone agrees on the state of the Bitcoin system, but no one controls it, you could ask the question of what makes it secure. And this is where mining is a part of the answer, but only that. Mining is this job in the network that is securing the network without a trusted intermediary. So we call it mining because you're awarded new coins. For miners are awarded new coins for kind of doing this job. But we should probably call it blockchain securing, because if you remove the mining, you also remove the security mechanism. However, it's really important to be aware that miners are only performing a task on behalf of the network. They are not controlling the network. A lot of people think that since miners are securing the network, that they can decide. They think that if you get miner concentration, that they can change the rules of Bitcoin, that the system can collapse into becoming centralized. But the fact is that the control over Bitcoin is actually divided by the different types of users. So between developers, miners, and users. Because it's software that I decide to run on my computer, there's nothing a miner can do to force me to run that software. And there's also nothing a developer can do to force me to run that software. I, as a user, decide what software I want to run. Miners come to the network and secures it because they are getting paid for doing so. And developers propose changes to the software that the users decide to run or not. So this is very similar to a board game where the protocol rules in Bitcoin is what kind of describes one board game, say Monopoly, but there's nothing in those rules that can stop anyone from creating another game, say Ethereum, or in kind of board game analogy, Risk. Also, there's nothing in the rules that can control how the rules can be changed. That's fully up to the users in deciding what code they are running. So the real power lies in this selection from the users in terms of what rules they want to follow, what software they want to run. At the same time, if they did a rule change where they stopped paying miners, there wouldn't be any incentive for securing the system. And if you are using the system to manage value in some form and it isn't secure, well, it isn't very usable. So the users can't freely change the rules to the disadvantage of miners. The same way that miners can't change the rule to the disadvantage of users, because if they did, the network would split. And if all the users remained on one side of such a split, well, that's where the monetary value would be. And that would be the coin that would have the ability to pay an electricity bill. So I heard that this was the last presentation today, so I do realize that this might be a little bit heavy at the very end of the day. And it's not really important that you kind of fully understand all of these details. The main thing I want to kind of bring home is just that blockchain is not the technology behind Bitcoin. Bitcoin can not be reduced to blockchain, and its security cannot be reduced to blockchain. There's a lot of different technological components that makes up Bitcoin from a technology perspective. But Bitcoin from a technology perspective is without value. You have to have the currency element. You have to have the kind of token incentivizing behavior. You have to have developer community contributing to the code and continuously updating, upgrading, building solutions on this. You have to have the whole kind of ecosystem around it. So it's primarily a social phenomenon where technology is one component and an enabling component, but not the core component. And this is exactly why you can't top-down redesign Bitcoin and make it better in a predictable way. It's also why you can't just take the concept from Bitcoin and easily apply it in some other context. So it's not the blockchain that's the technology behind Bitcoin, but it's actually Bitcoin, the cryptocurrency token, that's the technology behind the blockchain. Because it's the cryptocurrency token that incentivizes the behavior that secures the network. You can call the token Ethereum, you can call it Doge, you can have several other cryptocurrencies. So it doesn't have to be Bitcoin, but you have to have this token which holds value, because Nakamoto's innovation wasn't technological, it was game theoretic. So over to the more interesting thing. What can you do with Bitcoin and open blockchain, and how is it actually being used? Well, the most common use case that most people have noticed is speculation or investment. And in particular, Bitcoin is interesting here with its absolute scarcity and maximized security. So there can never be more than 21 million Bitcoins. And in a world where central banks are printing new money faster than ever, I mean, around 30% of the dollars in circulation, or in existence rather, has been created the last year. More and more investors, not only small retail investors, but kind of heavy hitters from Wall Street, are looking to Bitcoin as an inflation hedge. As an asset, it will be attractive to hold in case the national currencies, the fiat currencies, should lose money due to too much printing, basically, or too much spending from governments who have spent a lot, especially during the COVID crisis, but where kind of tapering that or kind of reducing that spending is something a lot of investors don't think will be politically feasible. So a little over a year ago, a very recognized investor called Paul Tudor Jones, one of the most kind of profiled macro hedge fund managers in the world, kind of sent shockwaves through the investment community when he said that his fund had allocated 2% to Bitcoin. And he pointed at two reasons. One, increased money printing. Two, society is increasingly becoming digital, and the young generation is becoming 1 year older every year, and they are much more inclined to invest in Bitcoin. So he strongly believes that Bitcoin can become some form of digital gold, a non-sovereign store of value, long-term, robust against inflation. So this is interesting for those who want to kind of manage a portfolio, those who want to invest. Of course, there's a lot of volatility, a lot of uncertainty, but that's also mirrored in the massive potential upside. Personally, I find the payment use case much more interesting and much less understood. Because a very sad side effect of the payment infrastructure we've had up until now has been that they've been closed systems. There hasn't been a way for a user of PayPal to pay to Venmo. There hasn't been a way for a user of Ipfs in Norway to pay to Swish in Sweden, because the networks were closed. You could only pay to a merchant using the same application as yourself, in stark contrast to the internet, where you can use whatever browser you like and still browse every web page. However, what is now starting to emerge is the possibility of going via Bitcoin as this layer of interoperability, as this global open standard, similar to how email is doing it. And what is super interesting here is to see that Revolut and PayPal and Cash App and several other such kind of fintech payment apps now have support for Bitcoin and other cryptocurrencies. Initially, they've rolled it out purely as an investment possibility, where you could kind of only buy exposure. But both PayPal and Revolut and Cash App now has features where you can actually send and receive Bitcoin. And this means that you can suddenly have a world where on Christmas Eve, you can go to your local provider and buy Bitcoin and send that to the other side of the world. And your friend in the US can receive that, and it can take seconds and have final settlement. And upon receiving, you can actually also have instantaneous exchange into the local currency of choice. So suddenly we are now in the process of moving towards a world where all of these different payment providers if they tap into Bitcoin or another cryptocurrency, they will be able to transact value directly between each other. And this is leveraging something that is truly transformational about Bitcoin, which is that it's a digital bearer asset. The value is in the object itself. All money we've had digitally before Bitcoin was in the form of a claim. If you hold money in your local bank, you hold a claim on that bank. If you hold money in PayPal, you hold a claim on PayPal. And the fact that all other traditional money is claim-based when it's digital means that you have problems crossing jurisdictions, because a claim is inherently linked to the enforcement of rule of law, which is linked to a jurisdiction, which is why cross-border payments is so expensive and so slow today. Because if I want to send money from Norway to, say, South Africa, there's no way for the receiver in South Africa to get money straight from DNB, which I'm using here in Norway. What you have to do is to find a chain of banks that trust each other in bilateral relations so they can exchange claim to each other through a chain reaction all the way until the receiver in South Africa hold a claim on his bank. The alternative, which is much more efficient, is of course for me as a Norwegian to buy Bitcoin, send to South Africa, and they can sell it locally. And actually I've done this. I participated in a crowdfunding of solar panels on a spar shop in South Africa. I invested like 400 euros. This crowdfunding could source investments from all over the world. And since they used Bitcoin as the payment rail, the cost became so low that it actually made sense. I'm getting my lease paid out once a month, and it's only possible to do that from South Africa to Norway for such small amounts because it's routed via Bitcoin as the payment rail. So this is just about to happen, and it ties into the investment case for Bitcoin because it's all the speculation and all the trading venues built out for those who want to trade that has pushed down the cost of exchanging from local currency to Bitcoin and out again so much that you can finally have a very low cost exchange back and forth, unlocking this payment flow. In parallel, we've also had a technological development around Bitcoin called the Lightning Network, which is currently growing exponentially. And it's a technology enabling instantaneous Bitcoin transactions outside of the blockchain, still secured by the blockchain, solving the scalable or scaling issues, enabling, actually in the most extreme case, streaming of money without the need of kind of more electricity consumption or more mining. And the Lightning Network, is what has enabled El Salvador to roll out, or not roll out, but to choose Bitcoin as legal tender, as the official currency. Because all of the apps in El Salvador and the state-backed app for this is using the Lightning Network. So you can have retail payments. In El Salvador today, if you go to a Starbucks, if you go to McDonald's, they both are obliged to and do accept Bitcoin as a payment over the Lightning Network. But it's not only nation states like El Salvador, and it'll be very interesting to see which other follows. But you also see this from some of the biggest tech companies out there. Twitter recently announced that they have activated Bitcoin tipping using Lightning on the platform. That means that you can, for now it's only in the US, but it means that you can tip content producers on Twitter instantaneously, tiny amounts, large amounts if you like, via Bitcoin. And the super interesting thing here is that while the user experience feels as if Twitter is processing this payment, what they're only doing is actually matching that simple user readable username, kind of human readable username of @Jack, for instance, with the long, difficult cryptographic key in a way where they're removing this complexity, but enabling direct payments. So it's the user paying directly to another user, which means that Twitter doesn't need any kind of payment licenses. They're not a money transmitter. They're just a facilitator of direct peer-to-peer payments. And this is something that will be truly transformational for any platform on social media, any platform on selling content, any platform having any form of interaction where the platform could actually serve the role as a matchmaker, but not having to deal with the payments. The other thing that Twitter is also rolling out is verification of NFTs, non-fungible tokens, which is the latest bubble in crypto. Most of you might have heard stories about pictures of monkeys, pictures of rocks or apes or something selling for ridiculous amounts of money. And yes, this is a bubble. No, I don't know when it'll pop. And even though it's a bubble, it's something fundamentally interesting here. So it's very similar to how we had the CEO bubble back in 2017. We've had kind of a bubble or bubbly tendencies in decentralized finance. There's something real happening here, but the market is getting a little bit too euphoric in the short term. To understand NFTs, it's important to understand that the token is not the image. The image file, when people send NFTs, is kind of just that, an image file that anyone can copy. What the token tracks, however, is ownership. And not ownership of the file in the sense that no one else can copy it, but ownership of the token or certificate of origination and authenticity. So if you have an artist that signs as this is such a certificate in the form of an NFT token, I can then prove that this artist has signed this as the original. So all of the rest of you who have kind of copied my picture, you own a copy, but I'm the one owning the original. The interesting thing here is, of course, that by creating such a token, you can tap into the whole ecosystem of applications built around, especially the Ethereum network, but also some of the other cryptocurrency networks. For the longest time, I was extremely skeptical towards the use of public blockchains in this way. My argument was that, well, if you're going to have an NFT tracking, say, a physical piece of art or a wine in some cellar, or even a digital form of art, but where it's the word of the artist, which is the ultimate backer, you actually have a point of centralization. You have that artist who claims this is the original. You have that warehouse where the wine is. So why use a decentralized infrastructure for it? Where I was mistaken there was that, yes, you could have set up your own database because it is centralized. But the problem is that if you did that, there wouldn't be any wallets, there wouldn't be any exchanges, there wouldn't be any third-party services that were ready to kind of integrate with your token. So by launching such certificates of ownership of origination on an existing infrastructure like Ethereum network, you can tap into that infrastructure and really tap into what Ethereum people call composability, that all of these components can be brought together. And that is extremely powerful. And it's also the reason why we see companies like EY building out technology for using the public Ethereum chain and have stopped most of their work on kind of private enterprise chains. And the list goes on. I mean, I could have talked for hours about the development of decentralized finance, where you use the programmability of kind of systems like Ethereum to create protocols for handling lending, saving, leverage, trading without an intermediary. I could have talked about how the self-sovereign identity might be kind of one of the really big shifts that are about to come over the next decade that can truly change how the internet itself is organizing, make ICANN, this entity that's keeping track of domain names, completely redundant. And it's super interesting to see how companies like Microsoft is putting in a lot of effort. They have a software or a program called Ion, where they're building out a system for managing self-sovereign identity anchored into the Bitcoin blockchain. So they anchor into the Bitcoin blockchain because it's the most secure timestamp server proof of existence log that is out there. They don't care about the monetary aspects of Bitcoin. They care about the security of its blockchain, which is a byproduct of Bitcoin being the most valuable crypto asset. And also it's worth mentioning that the standards for DID is also something that is coordinated in the R3 Consortium. So to round off and open for some question, what I really want to paint here is it's a picture where the internet gave us permissionless innovation for handling of information. It was never about using the technology behind internet to create intranets. The reason why cell phone internet connection has been so crappy and expensive for the longest time, roaming, was because telcos insisted on building their own network, not relying on the open internet. And in the end, it's of course the open internet that really transformed the world. And the internet lacked this kind of peer in an open system for managing information. That is kind of from 2009, when Bitcoin was first launched in live code and onwards, that piece has existed and is now experiencing rapid innovation, testing, trying. A lot of the projects will fail, but evolution will make sure that kind of the truly interesting project will thrive. And if you should focus anywhere in this space, it should really be on those open networks rather than the enterprise networks. Yeah, I think that was what I had planned for the presentation. And then I don't know if we should open for some questions or, yeah.
Absolutely. So thank you so much. Super interesting. So all your engagement with the crypto community has kind of blossomed into this arcane crypto thing you're doing. So can you explain what you're doing in your everyday in Arcane?
Oh yeah, absolutely. So Arcane was founded in the spring of 2018. I met up with a couple of Norwegian investors who found the crypto space super interesting. It was in the middle of the bear market, but kind of looking aside from the price, the market development had never been stronger. What we wanted to do was to take a position in this sector. And what we saw was that it was extremely fragmented, especially around the financial use cases. So our thinking was that, can we build Arcane in a way where we take this role as a consolidator almost? So what we have built is a portfolio spanning the value chain of financial services around cryptocurrencies. So we have brokerage, we have exchanging, we have market research, we have a fund for professional investors, we have payment technology. Right now, we have that in the form of kind of different brands, different entities, some fully owned subsidiaries that we have acquired, some where we are a minority owner. And our intention is to now, kind of going forward, to really bring all of this on one unified tech stack. So if you think about your bank, when at least if it's a good bank, when you log in, what you want is a menu of the different services. You don't care about there being different subsidiaries in the bank dealing with FX, with insurance, with savings, with share trading. You just want a menu. And that is what we are building. We're building one unified platform for users to learn, trade, and invest. We're building that on Google Cloud to have the scalability and avoid the need for a big DevOps team. And that is really kind of the next step and kind of where we are in our journey right now. As you mentioned, we are also listed in Nasdaq First North in Stockholm. And a key reason for the listing was that we intend to continue to do M&A, so acquire other companies where we do see a strategic fit with what we're building in the future, and where we can then take companies that has kind of developed, say, a very interesting service for reselling mining exposure, but where they have the full customer acquisition cost of doing only that, where they don't have a solution for the users earning cryptocurrencies to exchange that on the same platform, and where you don't have anything to resell to the same user base and bring that into a larger setup, enabling us to ideally bring down the customer acquisition cost from having a broader set of tools in how to acquire their customers, but also bring up the lifetime value from having the possibility of resell between OTC, the fund, mining exposure, other services in the future.
Awesome. I'm going to go ahead and ask some more. You touched on some very interesting topics just in the last few slides there. So some might know that Coinbase famously, or their CEO, had a Twitter exchange, or rather just a Twitter rant regarding SEC in the United States regarding their lend product. So you mentioned that people can lend using crypto services, but I think you mentioned DeFi, decentralized finance. Can you just share, if you're comfortable doing that, share like a concrete example what is a decentralized finance thingy?
Yeah,
what can
absolutely.
it do, and what are some of the innovative financial products you might find there?
Yeah, absolutely. So, but I'll start first, if it's okay, to touch on the regulatory question.
Sure.
Because for the longest time, crypto was so niche and so small, so regulators didn't care about it. And then they just warned about it. Now it has become so big that China has finally actually banned it. Now it's become so big that the European Commission is actually working on a cryptocurrency-specific regulatory framework called the MiCA regulation, which is to be pushed out in 2023. And regulators like the SEC, the Securities and Exchange Commission in the US, is kind of paying a lot of attention to this. We're now in that phase where the old world really meets the new, where a lot of the attempts are good intended maybe, but really misses the mark in terms of definition and understanding. So when Skype actually launched way back, regulators demanded that to have a Skype call, you had to have a 911 button. And the device that you were using had to have a backup battery. Every phone had this requirement, so you have to have this if you call someone online as well. Luckily, we don't need to have a 911 button in this call, and it's not illegal for me to not have a backup battery on my computer. So we're seeing a little bit of this happening in the regulatory space. I'm not saying that I'm against regulation. I'm just saying that some of the attempts to classify what a self-hosted wallet is, etc., really shows lack of actual understanding. It's also interesting here that a lot of the financial regulation we have is explicitly on third parties. So what happens when individuals themselves suddenly can do without the third parties? Do you regulate the individuals? Well, that requires a lot of new laws. Or that regulators are creative in interpreting cryptocurrencies in ways where they kind of get regulatory oversight. When it comes to DeFi, a lot of it is decentralized only in name. And we're seeing this where when suddenly you have DeFi platforms blocking different jurisdictions, etc. Still, there are truly decentralized applications. And I think there's a lot of them out there, but one that I find very, very interesting is MakerDAO. Because MakerDAO is replicating the combination of a banking system and a financial currency board, if you like. MakerDAO is a smart contract that is running on Ethereum. So this means that it's a script, a set of logic that is enforced according to the rules on the virtual machine on Ethereum, which is replicated across the network so that you know how it will run and you can't kind of you get consensus on how the code was running. MakerDAO has two components. One is the DAO token, which is a governance token. If you're a holder of DAO token, you have voting rights to change certain parameters in the smart contract. The DAI token, however, is actually a loan that you can take out. The way that DAI works is such that you post collateral. So let's say you have Ether or Bitcoin worth $1,000. You lock that in the smart contract, and you take out a loan worth $500. You take that out in DAI, which is a stable coin, worth $500. The locking, the posting of collateral, all of this just happens in the smart contract. It happens and it's enforceable because it's following, like it's a part of the rule set and what is controlled by the Ethereum network. Then suddenly you have replicated the whole way the banking system works. You post some collateral and you take out a loan denominated in the national currency. If I take a loan of $500 from my bank, I don't have $500. I have a claim on that bank of $500, and the bank has a claim on my collateral or my future time worth, well, if I post $1,000 in collateral, that would be what is securing it. The collateral is then called a CDP, a collateralized debt position. And the interest rate for taking out this loan is what's controlled by the DAO, the Distributed Autonomous Organization maker. The way the interest rate is set is to create a balance so that the DAI token holds its peg towards dollar. And very simplified. If the DAI token suddenly drifted away on the upside or the downside to the dollar, there are mechanisms in this lending protocol that would bring it back in line. And it can do so because of over-collateralization. So when you take out a loan, you can do that with collateral in a cryptocurrency. You can take it out denominated in dollars, and you can do so without using an intermediary. You're just using the smart contract. And the rules for that smart contract is set by the holders of Maker token voting, and they are in many ways deciding the monetary policy, if you like. This happens to be a monetary policy that would be run by a currency board, where the aim is to target another nation's currency. But you could also envision a future where they, instead of tracking the dollar, decided to track, well, say, price inflation, some other target. And you see then how it's not an individual that is voting. It's as a holder of the token that you're voting. Of course, a lot of arguments can be made here. How decentralized is the ownership of Maker tokens? Is it sufficiently? How is the participation? Are enough people voting? So there's a lot of challenges here. But the fact that there are hundreds of millions of dollars issued this way, and that MakerDAO has been running smoothly despite the extreme volatility and massive price falls, is remarkable to me. And then the super interesting thing is that, so other stable coins like USDC is centralized in the sense that there's a company, they issue a token, they have a bank deposit or not backing that, but it's an entity, it's a claim on an entity. It's the same as a money in PayPal, it's a claim on PayPal. The difference is that you issue that token on an open infrastructure rather than on a closed network. But with MakerDAO and DAI, the stable coin, the dollar-denominated DAI, is actually not centralized. It's self-sustaining in that it's backed by the collateral. And once you have that, then you can build trading systems. So you have, for instance, a trading smart contract called Uniswap, which is a way where you, if you want to be a market maker, you offer prices to someone. You say you post DAI and Ether to make a market in DAI and Ether. You just have a very simple formula where the product of those should be a constant, basically. And then you have a smart contract where you offer prices depending on how much people are buying or selling. I don't think there's a point of me going into the details here, but the interesting thing is that DAI is then suddenly reused in another smart contract, enabling trading without Coinbase or some centralized entity. So you start to see these layers of having these contracts talk to each other, the composability, which is becoming very powerful, because if you're doing that and the foundation is a centralized coin, well, that centralized point of failure, if someone pulls the plug there, if the regulator knocks on that door, all the architecture, everything that's built on top will collapse. On the flip side, of course, all of these smart contracts are so new. The type of technical roadmap you have on Ethereum is so radical that you should anticipate bugs and catastrophic failures in this phase, unlike Bitcoin that is extremely conservative and therefore maybe reliable as digital gold. But yeah, sorry, I'm talking away here.
It's truly fascinating stuff. Thanks.
But it's back to the permissionless part where you can then same thing also with the NFTs. So let's say I'm an artist. I draw a painting. I create a token, which is a certificate of ownership and origination for that painting. Then someone else, without my control, can fractionalize that. They can take that token, they can lock it and create 100 tokens and say, do you want to buy 100th of this certificate? That is something that you couldn't really effectively do before. Or I can also program in that if this token changes hands on the blockchain for a price that is visible on the blockchain, I'll get a payment every time in the future. So you have all of these possibilities that you didn't have if you had a physical certificate, where the physical kind of limitations of a piece of paper would kind of lock it to one country, would stop you from fractionalizing it and kind of re-merging it and all of that.
Awesome. Anyone else want to raise your hand?
There's a Pavel.
Yeah, may I?
Yeah.
Okay, I'm just wondering, what's your prediction about the Bitcoin when it will be reaching the final moments, like the top border of the value? No, of the quantity, like 20,000, right?
21 million coins.
Oh, millions, yeah, right.
Oh, yeah. So that's actually not a prediction because it's known, well, with close to certainty. I think around 18.5 million is already minted. So most of those coins are either in circulation or lost forever. And it's 2140 or something, which is the kind of the day when you have the final Bitcoin being minted. The way that mechanism works is that the system on average generates new blocks, updates kind of the log every 10th minute. It's self-calibrating so that when more people try to mine, it becomes more difficult. If fewer people mines, it becomes easier. And then the award is tied to these blocks. The award started with 50 Bitcoin per block back in 2009. And that reward is held every 4th year. So we had a halving in May last year, and it's now generated 6.25 Bitcoins per block. And it's this halving cycle, these kind of every 4th year, that is kind of creating a converging curve towards 21 million.
So how the market will like behave with the
Sorry?
knowledge, like if we reach certain
Yes.
quantity?
So these new coins is an important part of the incentives for miners to mine. But when you have a replicated network that is storing all transactions forever, you have to also limit how much data you can put into the blockchain, how much data you can put into the system. Otherwise, it would collapse. If I started uploading my family photos straight to the blockchain, it would collapse. That limitation, the block size limit, creates a queue when there are more people who want to transact than there is capacity. And as a result of that, you actually have a fee market. Miners are free to choose what transactions they include in a block, and they prioritize the highest payers. Of course, they'll take every transaction if the block is not full, but up until that point, they'll prioritize those who are paying a higher fee. So you're seeing fees making up a increasing part. It's very volatile for depending on the activity on the network, but an increasing part of the incentive for miners to keep the chain secure. Also, historically, the price of Bitcoin, the purchasing power of Bitcoin, has increased faster than the reduction in incentive, increasing the incentive and thereby increasing the security so far. So while this is a discussion in the community, it's like, will Bitcoin be secure in when there's no more Bitcoins to mine? Will the transaction fees be sufficient? My view is yes. Nobody knows, but it's far into the future that becomes an issue. If anything, Bitcoin is probably way too slow right now. It's probably too much mining because of the high value for the new coins that are generated.
Yeah. Oh, okay. So it's like a big unknown. And a second question is, can we like create the cryptocurrency which use not only to secure all resources from the all like miners, but to use it on the artificial intelligence or some machine learning process?
So there's a lot of coins and projects that have tried this, and none of them have been very successful. And the challenge is the different trade-offs. And by introducing another criteria for the choice of algorithm, you potentially get other kind of weaknesses in the system. So yes, you can certainly do so. There are certainly projects that have done so, but none of those have become very successful to date.
Okay.
And I think also one point that's important to make here is that people often hear about the enormous amount of electricity used for mining. And this is the type of thing where, depending on what you compare it against, it can sound really big or it can sound really small, even though it's the same amount of electricity consumption. So you can compare it, I think it's around 100 terawatt a year or something. And you can compare that to, I think, if I remember correctly, around the electricity consumption of Singapore or something. And that sounds like massive. But if you compare it to, say, flaring, so when you have oil extraction in rural areas, you get natural gas as a byproduct. And in many circumstances, you either ventilate it or you're obliged to flare it because it's less pollutive when you burn it. And if you look at the flaring in the US, which is 13% of the global flaring, that alone consumes twice as much energy, or kind of burns twice as much energy as the Bitcoin network is using. The reason why I'm using that as an example is because we now see actually an explosion in flare mining, where people are utilizing the possibility of, or the mobility of Bitcoin mining. They're putting them in containers right next to the oil extraction site with a gas to electricity turbine or a generator, and taking the gas that would otherwise just be flared for nothing and use that energy for mining Bitcoin. So you see Bitcoin mining being pushed to use energy that is otherwise trapped or lost. So it's important to be aware that electricity and energy is not kind of a homogeneous commodity. There are high transaction costs creating these bottlenecks. And since the mining itself is very mobile, you see kind of utilization of those bottlenecks. It's most profitable to do it where it's cheapest. And due to the increasing difficulty as more people mine, it becomes unprofitable to do it where electricity have high opportunity cost, where you could do other more valuable stuff with it.
Yeah, okay. So it's just self-regulation, and it will be probably just working in the near future for sure. Okay, thank you.
Yeah, and one, so it's another hand, but it's another point that is really, really important to make, which is, I touched upon it in the presentation, but a lot of people, both proponents and opponents of Bitcoin, think that you can reduce the concept down to some first-order principles and then conclude whether it will succeed or fail. The proponents say, well, it's hard money, you can't print more of it, it's decentralized, blah, 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 therefore it will be successful and will take over everything and will have hyper-Bitcoinization, no other currencies will survive. And the skeptics say, well, it's too volatile, it's unregulated, it's not backed by anything, and therefore it can't survive. Similar also when people are saying, well, it's not secure because of this, or it is secure because of this. You can certainly have these discussions, and it's useful to try to investigate these things and have hypotheses. But assessing the survivorship probability is actually something you only can do by assessing what it has done so far, kind of truly. So what I mean by that is that since this is an evolutionary system, and it's kind of an emerging system. There was never anyone top-down deciding that we should do Bitcoin. It's something that evolved from this 8-page document on an email list to where it is today. The only thing you can really know is that, well, it has survived so far. It has always been weaker in the past. If it should have died, it should have died kind of on those occasions in the past. So you have a very strong Lindy effect, where the expected rest time of Bitcoin is proportional with the time it has lived already. And you see this for other coins, where most coins, they have a period where they're very popular and then they die. Ethereum is different. Ethereum has shown substantial stayer ability. But apart from that, almost all the coins that were on top 10 in 2017 were something else than what was top 10 in the 2013 bubble, which is something else than what is on top 10 now. So in terms of understanding what is here to stay, I would strongly recommend looking at what has been here for a long time and proven itself already, because there's so many unthinkable ways that evolution could make a system survive. Even if, say, Bitcoin, let's say Ethereum moves over to proof of stake, no mining, no electricity consumption, everyone cares a lot about that, so everyone hates Bitcoin for using all its electricity. What you could actually then potentially see is a situation where all the coins on Bitcoin gets locked in a specific way and reappear on the Ethereum network in the same amount. So that, and you already have wrapped Bitcoins, so you have Bitcoins that are locked and then getting a representation as a token on Ethereum. So Bitcoin could survive even though the network died, because the network is social, and as long as the social consensus remained and absolute scarcity, kind of what makes Bitcoin, at least 21 million cap is a part of that. You could potentially see a world where all of the Bitcoins jumped over to another infrastructure. And this is just one out of a ton of different ways these things could play out, showing how impossible it is to map out the possibility space. Agatha?
Yeah, actually,
Agatha,
you
I
touched
don't know,
my
sorry.
question. Because my question was, what do you think? Is it possible that Bitcoin will change their algorithm model into proof of stake, or maybe invent something new?
I don't think you'll see that change in Bitcoin. Bitcoin's approach to code change is extremely conservative. First of all, they try as hard as absolutely possible to avoid so-called hard forks. That is, upgrades that becomes only doing upgrades that are backwards compatible, so that old clients not updating will still be a part of the network. Second, new code only gets committed and implemented in Bitcoin after a lengthy review process, and only if there's very widespread support for it over a long time. And the reason is because introducing new code brings a lot of risks in terms of bugs, and kind of the community around Bitcoin view that robustness as a key feature. That conservativeness is the only thing that can secure, can make you certain that it'll be here also a decade from now, 100 years from now. Changing the consensus mechanism within the network from proof of work to proof of stake is highly unlikely that Bitcoin will do. There's a ton of different trade-offs in a proof of stake system. There's a lot of changes in the security model. So a beauty with proof of work, for instance, is that it's objective in that it's anchoring the system to something outside itself. I can objectively get to chains and see and validate on my computer which chain has kind of spent the most resources on proof of work. In proof of stake, you can't do that. If you're presented with two different chains, there's no way for you, and both are valid, there's no way for you to validate. There's no cumulative work. In Bitcoin, if you want to change transactions way back in time, so rewrite old blocks, you have to work backward through all of that work that has already been done. Whereas in proof of stake, you don't have that problem. You also have issues with proof of stake like what is called nothing at stake, which is that if you have a chain split, the optimal thing to do as a user would be to stake in both chains. But that would mean that it would be very hard to converge on one true chain after a chain split. To deal with that, the idea is to introduce slashing so that the winning chain can then steal your money if they can see that you staked on both. But now, kind of very quickly, you start to see that, wait a second, adding these types of ad hoc fixes to these very deep challenges create their own new challenges. So long story short, I view it as extremely unlikely that Bitcoin would introduce proof of stake. If anything, it could be another project really succeeding with proof of stake, and then potentially the coins themselves traveling over to that chain. I think that would be more likely than the code in Bitcoin being changed that way. Yeah.
Thanks.
Yes.
I have a question, but I only can raise my physical hand.
Yeah.
I mentioned it tons of times before also, the size of blockchain. I mean, the actual megabyte, gigabyte, terabyte size of blockchain.
Yeah.
There is blockchain technology moving toward being actually used in real life, and the possibilities are endless, sort of. But there is no any actual use case yet, I think, or not that much. Still, the size of blockchain is going extremely big just by storing the transaction data. But what happens if, for instance, Amazon and eBay and AliExpress, for example, they are the biggest markets, integrate Bitcoin, for example?
Yes. So this is a very, very important question. Like, this is at the heart of some of the wars that actually have been in the community. So you had a block size war in Bitcoin. And if people are interested, I can highly recommend either listening to or reading the book called The Block Size War. Or maybe it's just me because I was around that time and I kind of remember the good old days and all the names, the kind of the people who were viewed as heroes and how they fell. But basically, it was this big discussion: how do we solve scaling? Bitcoin was starting to become more popular. The blocks got full. The fees started spiking. Some people thought that, well, we really need to increase the block size, allow for more transactions. While others said, no, we can't do that. That will be to just add another lane to deal with traffic. The problem is that you just get more traffic, and then what you do, build infinite amount of lanes. It doesn't scale long term, and it will collapse. And it'll also make the network more centralized, because if you allow for massive amounts of data, you cannot run a node on your computer anymore. You cannot validate. You cannot sync. You cannot store the full blockchain. You can only kind of have a pruned node where you can just have the latest. So some split out from Bitcoin with Bitcoin Cash, eventually also Bitcoin Cash SV, going for bigger blocks, while Bitcoin remained. We will not do a hard fork, and we'll keep the block size limited. They found a way to do a soft fork, so that's backwards compatible, effective block size increase, but still very limited increase. So how can Amazon, Alibaba, all of these guys use the blockchain without it collapsing or the fees going through the roof? And the solution is actually to use off-chain solutions. So to take an analogy, if you have a stable and predictable rule of law and legal system, and two parties have a dispute that is very clear from a legal point of view, you can settle easily without taking the case to court, because both parties knows exactly what would happen if you took the case to court. The Lightning Network, this is for transactions of Bitcoin, is built exactly that way. So the Lightning Network, I can open a payment channel to you, so we can set up a 2 out of 2 multi-signature transaction, which is time locked for, say, 2 months. If after that 2 months period, the money goes back to me, but during that 2 months period, both of us needs to sign to move it on the blockchain. If I then sign half a transaction of, say, a couple of cents, send that half of a signed transaction to you, you can then know for sure, cryptographically prove it, that you can add your signature and broadcast it to the Bitcoin blockchain and have final settlement. But since we have this whole month where this payment channel is locked, you don't see any hurry, because you also expect me to kind of maybe send you some more. I can then straight after send an updated payment where I send a little bit more, still with my signature, still missing your signature. And that way we can establish a local consensus between the two of us, exactly how much money I've transferred to you, enforced by the threat of using the blockchain, the Bitcoin blockchain, if we somehow disagreed. And since you can always kind of default back to settling on the blockchain, you can wait until the end of the month to do so. So this is actually live and being used. And this is a payment channel. The Lightning Network is a routable network of such payment channels. And this is being used today. It's still very early and very small, but it's at the same time what has enabled El Salvador to actually onboard 2 million people to Bitcoin and Lightning almost overnight without kind of the blockchain getting full. So that's for transactions. Then it's for handling of data. And here's the real important thing, is that there's very seldom situations where you want the data replicated. What you typically want is a structure much more similar to what they have in Estonia, where the different entities are storing their data, but you're taking digital fingerprints, so the hash of the data, and sharing that or anchoring that so that you can prove that it hasn't been tampered with. So you don't want to share all of the data replicated across all the players. You want to have a system for players to interact securely and knowing that the data hasn't been tampered with, knowing that the right entities are signed. For instance, if I'm, as an individual, proving that I'm older than 18 and Norwegian, you want a system that can deal with and checking that the Norwegian authorities have signed those credentials to me. But you don't want all of that data stored on the blockchain. And this is exactly what is being built with self-sovereign identity, where the only thing you anchor into the Bitcoin blockchain is the fingerprint of the whole system. Actually, and you have ways of aggregating cryptographically all the proofs through a Merkle tree and put that into the Bitcoin blockchain. And that is what's enabling all of the signing, all of the management of your identity, sharing of data, cryptographically proving that it's not tampered with, etc., outside of the blockchain. So in the same way as kind of the Supreme Court, or taking a case all the way to the Supreme Court, is extremely expensive, but if you have a truly trustworthy Supreme Court, you can do most things without doing it. It's similar in the blockchain world, that the most powerful thing you can do is to build your application outside of the blockchain, but using the fact that you could rely on the blockchain if necessary. And platforms are scaling exactly in this way right now. Also in Ethereum, you see a lot of innovation happening around so-called second layer technologies, these off-chain technologies. Also in relation to that, there's also two very interesting differences in philosophy and application of smart contracts. You have script-based smart contracts, which is what you have on Ethereum, where you have a programming language that defines what happens, like if this, then that logic. And the reason why it's enforced is because it's written as a part of the consensus mechanism, if you like. Then you have non-script or scriptless scripts, where what you do instead is to use the cryptography. To spend some coins, you need to be able to produce a signature. But that signature itself could be something that you could only generate if, say, 5 out of 10 signatures were combined. That signature itself can be the result of a cryptographically, mathematically smart contract. So you see a lot of the smart contract development around Bitcoin taking that path. Right now, in November, there's an update to the Bitcoin code for transaction format, which is called Taproot, which is introducing a new transaction format, which will enable much more advanced kind of off-chain scripts, or this way of kind of doing transactions and aggregating signatures in advanced ways. So the long story is, blockchains are powerful because it enables trust outside of the blockchain, so you don't have to rely on it. And there are several ways for different types of use cases that scaling is being solved. And never ever put a ton of data into the blockchain. That's a replicated database storing everything forever is not the data structure you want for storing data.
Can I re-explain what I understood in English?
Yeah, absolutely.
Sort of, for example, in a museum, instead of storing all the big drawings in luck, take a small, very detailed picture and store those pictures, and the next time you want to check if it is the original one, check if they match, sort of.
Yeah. So in many ways, by taking the fingerprint, the hash, you can make sure, then you can generate tamper proofs.
Yeah, then this data can be stored anywhere, and people are free to tamper with it, but you know that it is not the original data.
Yeah. That said, though, it's interesting because it's not really blockchain, but you have something called IPFS, nothing less than interplanetary file system, which is building out a way for having decentralized storage. So normally when you look up content online, you look up a position. So it would be like going to the library and ask for the book on shelf 8, position 13. With IPFS, instead, what you do is you ask for the book that generates this fingerprint. So you basically would be saying, you're calling out, I want the Lord of the Flies. And IPFS there's actually someone who's then created a project called Filecoin, where they combine a cryptocurrency token with this way of looking up data and kind of having data positioned to incentivize nodes to store parts of the data. And the really cool thing here is that then, well, personally, I would say it would make more sense to use Bitcoin as the payment token, because the whole thing you want to do is to pay people for making their hard drives disposable. But that's another story, whether you need a special purpose token or a general purpose token. But the really interesting thing here is that by having cryptocurrencies as these programmable, borderless, censorship-resistant value objects, you can suddenly incentivize things like Tor routing, like making your hard drive available to others. And combining that with cryptography, you can actually store only parts of a file. So you're not, or at least you can make the argument that you're not running the risk of storing something illegal, because you're only storing parts of a hash. There's no way for you to, it's not the whole thing. It's like storing ingredients. And it's only the person then pulling those ingredients that gets the full picture. And this is actually being live and used in apps that use IPFS for kind of storing all the content on the app, so that the app is calling this from IPFS as a file storage network or technology, combining that with cryptocurrency payments on the platforms, and combining that with self-sovereign identity and decentralized identifiers. So you had a project, which I don't think is running anymore, called Open Bazaar, which created a decentralized and open version of kind of Amazon by combining Blockstack for identity management anchored into the Bitcoin blockchain, cryptocurrencies as a payment rail, and IPFS for storage of the kind of the pictures of the things that you were selling, for instance. So these things are live and being used in apps in different forms today for different reasons.
Thank you.
Okay. Thank you very much. Are there more questions?
There are more questions, but not more time.
Okay. So thank you for being with us. It was a real pleasure for us to hear you.
Thank you for having me, and I hope it was not too heavy at the end of the day, and at least it was some interesting for some, at least.
Sorry, it was heavy.
And interesting. We want to ask, where can we follow you and where can we learn more about Arcane?
You can follow me on Twitter. I think if you search for I need to get a better Twitter handle, but you can find my name. I guess, I don't know, I guess it's shared somewhere, and then if you Google that, you can find me on Twitter. Arcane.no is the homepage. It's not. we need to get better. Like we are doing investor relations enough to be compliant, but not enough to be really understanding what we're up to. And it's a part of the reason is also that we are in this transition where the company right now looks like a holding company spread across the crypto sector, and we are about to turn that into a product and tech-driven company unifying this. So, but arcane.no, you'll find more information. But Twitter is where most things crypto happen. So yeah.
Awesome. I want to add, if you wanted to mention a personality or two in the crypto space that we should follow on Twitter, do you have any suggestions?
I think following, if you're new to this and want to explore the field, I would definitely recommend the YouTube videos and presentation by Andreas Antonopoulos. It's also been transcribed in a couple of books, which is more efficient and and then you know that you don't get too much overlap because he has done a ton of presentations. These are really good. It's a really great place to start to kind of understand this from like the paradigm shift, but in very plain English, and is a great presenter. I think also following Jack Dorsey, the founder of Twitter, is interesting because he is both and also founder of Square, the company behind Cash App. So he's on the one hand a really successful entrepreneur, but also a very interesting visionary and has very good understanding of this field. And then in general, it's really hard to give then, apart from Andreas and Nobles, I think it's hard to give general recommendations because it really depends on what part, like whether you're interested in the technical part, whether you're interested in the philosophy part, the money part, the trading, and most of these people have they are half brilliant and half crazy. So there's a lot of so-called Bitcoin maximalism out there where you find people who are super interesting when they talk about some of the things in crypto, but suddenly they are hardcore anti-vaxxers and meat only for breakfast. And if you're not eating meat, then you're kind of weak. And it's like it's also a little bit if I recommended one of those, it would feel a bit strange because yes, they have content that I find very valuable and very teaching, but also I don't necessarily want to have people thinking that that's not my views on most things as well. Yeah.
That's a very thoughtful answer. Thank you so much.
But Andreas Antonopoulos can safely be recommended, in my view.
Okay. So, a big hand, or rather, let's shake our hands for Torbjørn Jensen. Thank you so much.
Thank you. Have a good evening or afternoon. Yeah.
Take care. Bye-bye.
Take care. Bye.
Bye.